So this is Unit 3 F notes. This is graphing radical functions. So here we're going to just be graphing radicals. Try to do this without a calculator. We're going to go through domain, range, and end behavior. So first thing you do, you have x and y. If you substitute in a number, think about what number you could substitute into this radical that would make it a nice, like a perfect square. So the first one would be like 1. Put 1 in, square root of 1 is 1. You could even do 0. 0, square root of 0 is 0. If you put 2 in, square root of 2, I don't know, 1.41, but that's not nice. We want nice integers. So think about the next one would be 4. Square root of 4 is 2. And the next one that would be a nice number to do with, it would be 9. So 9 square root of 9 is 3. So let's plot some of these points. 1, 1, 0, 0, 4, 2, and 9, 3. So taking a look at the graph, if we did like -1, square root of -1 is I. And there's no i's on this graph. It's an imaginary number. So therefore, this graph starts at 0, 0. And it's kind of it's a sideways parabola. I'm not drawing it the best. I'm not doing it a very good justice here, but it's a sideways parabola, just starting at 0, 0. So the domain starts at 0, 0. So the first x value is 0, and it starts there, so it's a bracket, meaning it's. Let me start that over. So it's a bracket. The x values start at 0. Bracket means that it's included. There's a filled-in dot here that's included. There's an actual point at 0, and it goes to the right, and it goes on forever and ever to infinity. And infinity is just a thought, just an idea, so it cannot actually get there, so it's not a point that's included. The range. In this case, the range is the y values. The lowest y value is again 0. And it's going up, up, up. As it's going to the right, it keeps going up. Up is the y values, and that's range, and it's going to go to infinity. It'll get to infinity a lot slower than domain will, but it'll get there eventually. And then end behavior. This is as x approaches. And since now there's not, x cannot approach negative infinity, x will approach actually 0 is the farthest left, the end of this graph. What is the y going towards when x goes towards 0? So as you're coming down the line, as x approaches 0, the y also approaches 0. This point is 0, 0. So as x goes to 0, the y goes to 0. And then we have as x approaches, look at the other side of the graph, as x approaches infinity, what is the y values doing? The y values are, as x goes to infinity, the y values are slowly going up. They'll never stop going up. They'll keep on going up to infinity. So that's what we're doing today. The next one is the cube root, cubic function. So a cubic function, so we're going to have x and y. I guess this should be for f of x. The last one should have been f of x, not y. But f of x, you can represent it as y. So we have what numbers can go in for x into the cube root that will be nice integers. So if we put 0 in, cube root of 0 is 0. You could also put 1 in there. Cube root of 1 is 1. If I put 2 in, cube root of 2, I can't do that, not as a rational number. So let's think about some other ones. We have 8. Cube root of 8 is 2. Could we do negatives here? So -1, cube root of -1, that is -1. And the cube root of -8 is -2. Because you can go the other way. -2 cubed is -8. So cube root of -8 is -2. So let's plot these points. 0, 0, 1, 1, 8, 2, -1, -1, and 8, -2. So what kind of graph is this? So what I do is I start in the middle, and it's the right side is just like a similar shape to a radical, so square root, and then it's just the upside down version of the same thing. So it's kind of snake-like. It kind of goes up and then over. I always start in the middle of the drum, and they look a lot nicer. So the domain of this function, how far left does it go? It keeps on going to negative infinity. How far right does it go? Keep going, go, keeps going to infinity. No brackets because those are not numbers. Range, what's the lowest y value? Well, they'll keep going. There's no stop to them. So that's negative infinity to infinity because it'll keep going up too. Remember, you can also represent this as x is all double backboned r, all real numbers. You could say that. And then end behavior, as x goes to, well, look, on the left side it can go to negative infinity. The y values, f of x goes to, and they're slowly going down, but they're never going to stop going down, so that's going to end at negative infinity. As x goes to positive infinity, the y values, so we need to think about this again on the right side. As x goes to positive infinity, so it's going to the right, is it ever going to stop going up? No. So it'll go up to in positive infinity. So those are your end behaviors. Last problem. So if we have a cube root, not just a cube root of x, but a cube root of x plus 5, subtract 1. Still have I work out a table here, x, y, or f of x. Think about what numbers can you put in for x that will make that you could have a nice cube root. So from our last example, we know we can do the cube root of 0. So what x could we put in to here that will make this 0? That would be -5. Because -5 plus 5 is 0. Cube root of 0 is 0 minus 1 is -1. And we also want to make this 1. So that would be -4, so we put -4 plus 5 is 1, and cube root of 1 is 1, minus 1 is 0, so we have -4, -4, and 0, and we could make it, and we got -1, so that'd be -6, -6 plus 5 is -1, square root of -1 is -1, minus 1 is -2, and we got, what are our other numbers? We have -8 and 8. So 8 would be 3. So if we substitute 3 in for x, that's like 3 plus 5 is 8. Our cube root of 8 is 2. 2 minus 1 is 1. And we got -8, so that's -13. Plus 5 is -8. And cube root of -8 is -2. Minus 1 is -3. So graphing these, -5, -1, -4, 0, -6, -2, 3, 1, and -13, -3. You can go off the graph. This is all just estimation. So the middle is right here with these 3 points. So draw your square root function, both sides. So the domain of this hasn't changed. X, all real numbers. The range, still all real numbers. End behavior hasn't changed. So it's as x goes to negative infinity, the y goes to, and as x goes to negative infinity, the y's are continually going down smaller and smaller. And as x goes to infinity, the y values go to, and that's on the right side, as x goes to positive infinity, getting bigger and bigger and bigger, it's going up to infinity. All right, come to class with any questions.